All right, there it is. So let's get started just right off. Let's get some vocab going on. We're talking about markups and discounts today. Markups and discounts are an application of percent of change. Just what they are. Markups and discounts are an application of percent of change. Think about it. If the idea is, hey, I've got 25% off sale, isn't that a percent of change problem? I'm changing the percent from 100%. 25% off becomes what percent? What percent, Allie? 75%. That's a percent of change problem, right? 25% off is 75% of the original price. Or what if, let's say, our price was originally $20 and now it's $10? What percent off would that be? That'd be a 50% off sale, right? Because it was originally $20, now it's 10. That's a percent of change problem. Right? What was the change? $10. So we're going to talk specifically about this because this is more application-based. All right? So markup is the amount a price is increased to make a profit. Start writing. Start writing. Yeah, there you go. Good. We need to fill in some blanks because we got to get some definitions in here. Markup is the amount a price is increased to make a profit. It's what the stores do. They purchase an item, then they jack the price up, and then they sell it to you. That's how they make a profit. That amount that they sell it for is called the selling price. That's the markup added to the cost. Cost is the price that the store pays. Okay, so we're going to do markup first, and then we'll do some discount. So here we go. This is our key idea, right? You got to be more engaged. Percent of markup and the discount equation. Notice I only gave you one equation this time. Why? What do you think? Because it's the same equation. Same equation. Markup and discount are the same thing, except one gets increased to the original price, one gets decreased from the original price. Now, if you flip your notes over real fast, you'll see the shortcut method is on the back. The shortcut method is when you add percents or subtract percents. First, we're going to do it where you add prices. Sometimes this clicks better with people. Working backwards problems, you'll have to use the shortcut method. Working forwards problems, you'll be able to use this. Working backwards problems, where you have to work backwards to find the original price, you won't be able to use this method. Just throwing that out there. But if you're looking to find the selling price or the sale price, or if you're looking to find the amount of markup or the amount of discount, this method is fine. Okay. Let's do a markup problem right away. Let's just go right into it. So, the original cost of an item is $40. So a store purchases a bike helmet for $40. That's name brand. Then they mark up the price by 25% so that they can make a profit. What is their amount of markup? Well, let's do it. A equals P times W. What's P going to represent here? Percent markup. It's important that we decide what A and P are. We have to identify what they are. You don't have to write it down, but you need to take a moment and decide for yourself what A and P are going to represent. So P is percent of markup, and A is amount of markup. W is the original, just like it has been for a while. So now A equals 0.25 times 40. So A equals $10. Now why didn't I go ahead and subtract that 25% and get to 75? Because what was I looking for? The amount of markup. So I'm not gonna change the percent, right? Because if I'm given percent of markup and I'm looking for amount of markup, I don't want to change the percent. I'm looking for the amount of markup. It's $10. So what's the selling price then? $50. How'd you get it? 40 plus 10 is $50. Right? That's what markup is. Markup is the price increase that a store makes to make a profit. Great idea. actually said, what if we just did 1.25 times 40? Would that get us this? Absolutely. Would it get us this? No. So we have to pay attention to what we're looking for. So if we're looking for the selling price, then absolutely we want to do that. And that's what we're going to do on the back of these notes. If we're looking for this, we need to make sure that A represents the amount of markup. So P needs to be the percent of markup. Cool. Great question. All right. If you're a proportion person, this is what it would look like. A is the amount of markup, W, percent markup. If you're a proportion person, that's what you would do. Okay. So you're just checking your proportion work. Question proportion, people? Okay. Vocabulary again, back up to the top. Discount. Make sure you're engaged in what we're doing. We got to make sure we get these words written down. We're back up at the top. Discount is the amount a price is decreased for a sale. So when we say 25% off, you don't save $25, you save 25% of the original cost, right? Or if we say 40% off, that's 40% off of the original cost. Now the sale price, that would be the original price minus the discount, which we can go straight to using percents, right? 100% minus the discount, 100% minus the discount, percent. But if we're looking for the discount, we won't want to decrease those percentages. All right, so once again, it's the same exact equation. This time, we're going to focus on the discount part. If I'm looking for the amount of discount, I need to use the percent of discount. And then I can subtract. Here's my discount example. Hey, look at those numbers. They're the same numbers. So, since it was the same equation, we can show the exact same work, right? A equals P times W, where P is the percent of discount. Why do I want to leave that as percent of discount and not change the percent? Because what am I looking for? The amount of discount. So I don't want to change this percent. Those of you who are really good at changing percents, like adding or subtracting from 100, this might frustrate you a little bit. I want to subtract the 25%. This is the amount of discount. And this is the original. So A equals 0.25 times 40. We already know the answer to that. A equals how much money? $10. So the amount of discount is $10. So that means the sale price is 40 minus 10. So how much money? $30. All right. So the key here is making sure that since it's a sale price, that it's minus, right? Sale price you'd be decreasing. Wouldn't you be, I mean, this makes sense. Markup increases price. Discount makes it cheaper. If you're a proportion person, here's what your work would look like if you prefer the proportion. Same exact steps here, the only change is that you're subtracting. All right, there are two problems down there. I want you to work through them with your partner. One is a markup and one is a discount. I want you to find first the thing you're looking for, and then find the selling price or the sale price. All right? You can pause this video, try them. This is example 3. Check your work. Okay, so the reality is here, we have to make sure that you decide what A, P, and W represent. Okay? Now let's take a look at another way we can go straight to sale price or straight to selling price. Because sometimes you want to know what's the actual price I'm going to pay. The fast way is what I'm going to show you now. All right? Remember with percent of change how we could add or subtract from 100? Remember that? It was faster. Let's be honest, it was faster. And I think you guys kind of got that a little bit. It seemed like you guys kind of caught on. Okay, I can add or subtract from 100%. Makes it a little bit easier. Percent of increase, I would add to 100%. Percent of decrease, I would subtract from 100%. So in the terms of markup and discount, Which one's going to be an adding to 100%? Markup or discount? Markup will be adding to 100%. Discount will be subtracting from 100%. And why would I want to find that? Well, if I want to go straight to the final price or the final amount, that would be called the selling price or the sale price. If I want to go straight to the selling price or sale price, this will be a faster way of doing it. Okay? So let's look at example 8, or example 5, excuse me. A jacket costs a store $134.98. If they have a 55% markup rate, what would the selling price be? Okay? So this time, A equals P times W. P is not going to be percent of markup. I'm going to have P be percent with markup. How does that change what I'm doing? Instead of percent of markup, I'm going to do percent with markup. Well, because 55 is not going to be P, I'm going to have this be 100% plus 55%. That'll make it so I can go straight to the selling price. So that's percent with markup. A is then going to be the amount with markup, also known as the selling price. Right? Look back up here, right? The final amount with the markup. That's how much they would sell it for. And of course, W is going to be the original. So that's W. So, what am I going to plug in for P this time? Sorry, 1.55 times 134.98. Now, could you use the other method, where you find the markup and then added it? Yes. To me, this is faster. And it only will work if you take the moment and take the time to decide what A and P will represent. I'm trying to hit this home. You have to decide for yourself what you want A and P to be. If you want P to be the amount of the percent of markup, A needs to be the amount of markup. If you want A to be the selling price, which is the final amount including markup, then P needs to be the final percent including markup. A and P should have the exact same phrasing, and you have to decide for yourself which one you want it to be. All right, and those of you who all did your calculators, because you are following along, what'd you get? So these people are the only people who did any work right now? Let's go. Be engaged. I know it's not Friday. Be engaged in your learning. Engaged in something. What else is it? Engaged in your learning. Engaged in making FJH a better place. Charge of pride. 209.22. And that's what this is. This is the price, the selling price, the price that includes the markup. Questions? The next one is going to be the opposite of that. It's going to be the sale price. So I want to do the shortcut method on this one. A, P, W. But I don't want P to be the percent of discount. I want it to be the percent with discount. Because I want A to be the sale price. That's the price with the discount. Isn't that what the sale price is? It's the price including the discount, like with the discount in there. So P is the percent with discount. How do I find the percent with discount? How do I find the percent including discount, Jack?
Subtract by 25.
Yeah, exactly. So 25% off would be 100% minus 25%. This is W, and that would be A. You with me so far? So A, we don't know. P is going to be what? 75% times original cost, $35.90. calculator people. Make sure you round correctly on this one. Yeah, go ahead. $6.93, and it should make sense that it's cheaper, right? Because it's 25% off. Once again, what mattered was what you decide A and P to be. If you didn't want to go straight to the sale price, if you wanted to first find what the discount was and then subtract, you can. I think this is better, my personal opinion. But that's because I've practiced these things and I've been able to distinguish, all right, this problem, I need A to be the sale. So that means I need P to be the sale amount, the sale discount. Right? One last one. The discount on a toy robot is 40%. It's now on sale for $54. What did it originally cost? This is the percent discount. If you liked the other method where you find the discount and then subtract, it will not work for this method, for this kind of problem. Any problem where you have to find the original amount, you cannot do the first method we did. You can't. You have to do the shortcut method. You have to. This is the final with discount. So you have to be careful here. What did it originally cost? That's W. So A equals P times W. What were we given? We were given the final amount with discount. That's the selling price. The selling price, or the selling amount, which means P cannot be 40%. It has to be the selling percent. The selling percent is the percent with discount. That's the key. W, of course, is original like it always is. You can change the percent. We can't change this. We don't know how to change it. How can we change this? Well, we can subtract it from 100. So selling price is 54. The selling percent, what's the actual percent we paid? Exactly, 100% minus 40%. Why minus? Yep, discount. Minus, right? Times W, which we don't know. So 54 equals 0.6 W. We divide both sides by 0.6. And what would be the original cost? It should be larger, right? by a good amount? $90. It's a toy robot. It does things for you. Robot, pick up my clothes. Robot, clean my room. Okay.